to Master T Math class. And in this live class, we want to continue from where we stopped in our previous live class. We are looking at the topic circle geometry. Circle geometry. And this is one of the important topics in mathematics as far as mathematics is concerned. And we're able to look at the definition of circle, some part of the circle, able to recognize the radius, the diameter, the chord, arc, sector, segment of a circle, and also we deduce some lemma before we move to theorem 1. And we discovered that a chord can either subtend angle at the center of the circle, two angles at the center, and also two angles at the circumference. And for the theorem 1, what we have there states that the angle at the center, or better, we can put it as the angle subtended by a chord or an arc at the center of a circle is twice the angle subtended by a chord or arc at the center of a circle is twice that which it subtends or subtended at the circumference of the circle. Now, this is what the theorem 1 is talking about. That is the angle that a chord or an arc subtend at the center of a circle is twice the angle subtended at the circumference. Now, this means when we draw a diagram for that, we look at the proof in the previous class. We can as well check that proof. That is, when we have a circle with center O this way, and we have a chord. Let's call this chord AB. Then the angle subtended at the center by this chord. We have this angle. Actually, there are two angles here. The one inside there and the one outside there. That's the opposite zone and the reflection. Now, let's consider the one inside now. That is the angle at the center here. Is now twice the angle at the circumference that is formed by this chord as well. Now, join another angle at this circumference here. This angle here is at the circumference now. We call it angle ACB, which implies that angle AOB at the center here is now 2 times angle ACB. That this angle at the center is twice the angle at the circumference. Now, let's put a letter here. For instance, if angle at the circumference is x, what will be angle at the center? 2 times this, that will be 2x. So that's what the theorem 1 is talking about. And there is a proof for that, actually, which is very interesting. The understanding of that proof will help us to solve problems in geometry or circle geometry related to that. Now, this is not the only possible ways of having this. Now, we said there are two angles at the center, right? When we consider this angle as the angle at the center, its corresponding angle at the circumference will be at this side. That is this angle here. Okay? So that is why if this angle is at the circumference, let's call it D here. So also angle ADB is at the circumference. We can label it as Y. Then the angle at center to that, which is this reflex angle, is now going to be twice of this, which is 2Y. So it's very important for us to understand this particular theorem. One, when we understand this, is like the basis for circle theorem. So that is that. And there are some things that also we should understand here. This center of the circle is angle at a point now. And sum of angle at a point is what? 360 degree. For instance, if we know this angle, we can as well get this angle by taking this angle away from 360 degrees. All right, you are watching us here at Master T Math class, so do it to subscribe and stay tuned. Give a thumbs up to this video and also share it. Now let's look at where we stop. There was a question we were given to solve that is related to theorem 1 here. We have this question. This is the center of the circle O. We have this radius. This is a radius, this is a radius. And we have this angle formed by this arc. This arc AB subtend this angle at the center, and it is called 130 degrees. And also subtend this angle as circumference. This is not given, actually. This angle is not given. And we are given 26 degrees here. And there is a line, like a construction line connecting C and O, and extend to another point here. Now, what the question say we should find? The first question say we should find the value of angle CBO. And the second question say we should find the value of angle BOC. Now, where we are going is where we start from. Which angle are we calculating in the first question here? We are finding the value of angle CBO. CBO. B is at the center. So it's like we are moving from C to B and from B to O. That's CB, then BO. So the angle here is what we are finding for number 1. And number 2, BOC. So O is at the center. We are moving from B to O and from O to C. So we have BO, then OC. So this angle is what we are finding for the second one. Now, if we have this kind of problem in circle geometry, we don't need to worry about what we are finding first. What should come to our mind now is what's the first thing we can do here? That is, how can we get this question we are asked to find? So that's what we come to our mind now. Then, merely looking at this diagram, it follows from the first theorem, because we can see that angle 130 degree here is at the center. Is at the center because it's center whole of the circle. And once we have angle at center, and we can see that there is an angle at the circumference, theorem 1 will come to our mind. Now, which angle is at the circumference here? We have angle ACB. From A to C, from C to B. So this angle here is at the circumference. So we can say that angle ACB now will now be equals to 130 degrees over 2. Why? Because angle at center This is the short form of angle. Angle at center is equals to 2 times angle at circumference. So this is a short form of circumference. That's the first step. Once you can see that these angles are the circumference and these angles are the center, we will be able to get this angle now, irrespective of that's not what we are asked to find. Okay, but there is need for us to get that. Now that we have that, we can say that angle ACB now is equals to 65 degrees. Okay, now we don't have to write it inside this diagram. Let's just keep it. We know what we have calculated, which is angle ACB. Okay, now looking at this diagram as well, if we understand theorem 1 very well, there is something here that we need to see, because anytime we have center of a circle, a line that is drawn from a center to circumference is a radius. So AO is a radius, CO is a radius, making two radii that form side of a triangle ACO. Now, triangle ACO is now what type of triangle? We can say this form, short form of triangle. So we say triangle ACO is what type of triangle? An isosceles is an isosceles triangle. Why is it an isosceles triangle? Because AO, this line AO is equals to line CO. Why are they equal? Because they are radii of the same circle. This is very, very important, because understanding this alone is very important to solve this particular problem. Okay, now that we have seen that this triangle ACO is an isosceles triangle because these two sides are equal. Now, the base angle of an isosceles triangle are equal, because whenever we have an isosceles triangle, two sides are equal. That's first criteria, and also the base angle are equal. So whatever this angle is, this angle will be. This angle is X, this angle will be X. So that's under plane geometry. Is like a pre-knowledge. This previous knowledge, what we need to have known before we move to the circle geometry. Now that we know that we can get this angle now, I believe we are following. Sorry, we are taking time just for us to understand it and be able to apply when we see another question that is similar to this. Okay, now this angle marked, we can label it using 3 letters. How do we label that? We should be able to label angle very well. Okay, please do something for me. You can share this video. It doesn't cost you anything. Just give a thumbs up and share so that it will go to those that need kind of videos like this. And God bless you. Thank you for sharing. Now, how do we label this angle that is marked? When you look at it, it's between two lines. Which line? Line AC and line CO. So those are the 3 letters you will use. You will use ACO. So we cannot say that angle ACO is also equals to 26 degrees. Why? Because you must have a reason for everything you have written. This angle of isosceles triangle AOC. So we can put 26 degrees here now. But before, look up. Sorry. Let's pay attention to this. Before, we have discovered that all this angle here at the circumference should be 65, right? Now that we have 26 degrees here, we can get the remaining angle here. Half. By taking 26 degrees away from everything here, which is 65. So, which means that this angle marked here, which is angle BCO, labeling angle is not a problem again, which is angle BCO, CO. So we can say angle BCO is now equals to 65 degrees minus 26 degrees, which is equals to 39 degrees. So this angle now is 39 degrees. That makes everything here to be 65 degrees. And what next? Similarly, this angle we are finding now is also same thing with this. Why? Because this triangle BOC is also an isosceles triangle. Okay? How is this an isosceles triangle? Somebody can see that line BO and line CO are same thing. Both are radii, making two sides to be equal. That makes it an isosceles triangle, and the base angle to are equal. So this is 39 degrees. So we can say that the first question now has been answered, that this angle CBO is equals to 39 degrees. Why? Base angle of isosceles triangle BOC or BCO. So that is that. Then the second question here is the one marked here, which is angle BOC. BOC. Now, okay, I believe we are still together. We have this triangle now. This two angles is already known in a triangle, you know. Sum of angle in a triangle is 180. We have three angles in a triangle, and the three angles should add up to 180 degrees. And once you know two angles there, easily you can get the third one. So there is no problem about this again. So we can see that the second question here now, which is angle BOC, is now equals to 180 degree minus 39 plus 39. That gives us 78 degrees. So that's sum of angles in the triangle. Then we now have 180 degree minus 78 degree, that's 102 degrees. So we have already answered this question. Once you put something like this down, that is well backed up with a reason, it shows that we have the understanding of that theorem, which is theorem 1. So thank you for watching so far. So do well to give a thumbs up and also watch the end. Share this video as well. If you are joining us for the first time, you can subscribe to this channel. It's the right channel for you as far as mathematics is concerned. Okay. Then now let's sit down. Let's move on here and we look at the second theorem. And from the second theorem, it proves from the first theorem. And that theorem says that the angles obtained by a chord or an arc in the same segment of a circle are equal. Now let's put it down and draw the diagram and see the proof relating it to the theorem 1 that we have proved. Okay. Now let's look at the second theorem. The second theorem here that we are considering, we call this theorem 2. This theorem says that all the angles obtained by a chord, all the angles subtended by a chord or arc in the same segment. That's a very key word. In the same segment of a circle. are equal. Okay, now let's consider this theorem. It's a very, very interesting theorem as well. We can draw the diagram here. We have a circle. You have a circle center hole. Okay. Then the theorem say all the angles subtended. Subtended here is like a word formed. It's just an English word. We can use the word form. Formed by a chord or an arc. We can be considering a chord or an arc. In this case, let's look at the chord. Let's call this as a chord AB. A chord is a line that's drawn that join the 2 points on a circumference. Okay, so let's call this a chord called AB. And all the angle formed by a chord in the same segment. Now, this chord has already separated or divided this circle into 2 segments. We have this smaller one and this bigger one. This smaller one can be called the minor segment, while this bigger one can be called the major segment. Now, let's form angles on this major segment. All right, I believe you are following. Okay, let's form angles on this major segment here by this chord AB. So all the angles will be coming from AB and will be forming at the circumference, at the upper segment. So we can form this first one. So it's joining point AB. We call this the first angle. Okay. We form another one joining at this segment, at this circumference, coming from AB. We form another one. It might be as many as possible. Also joining at this circumference. So it doesn't matter how many angles we form. So in as much as it's coming from this chord and in one segment, everything here, all this angle here are said to be equal. So this angle is equals to this angle, is equals to this angle, is equals to this angle. That's what the theorem is saying. All right. So practically, if you have a problem like this, and the question just draw something like this, and they said you have something like this, and like this, and they give you 50, or let's say 50 degree here, and they say find the value of x without doing any extra calculation. X will be what? 50 degrees. Wow, they are in the same segment. Angles obtained by a chord or an arc. Even this line might be removed. If this line is removed, it implies that this arc is what we are considering. And this arc is forming these angles here. And this 50 degree now and this x, they are in the same segment. So therefore, if this is 50 degree, this also should be 50 degrees. Okay, I believe we are getting that. We are still going to look at the reason why it's like that, and which we will see now. So in the same way, I can put 60 degree here. So what will be this angle? If I label this as y, what will be this angle y? It's also be 60 degree. They are in the same segment. When we look at it from this side, this arc now is one forming this angle here, and these two angles now are the same segment. So which implies y and 60 degree are in the same segment. So this angle too should be 60 degrees. All right. Now, why is it that all these angles are equal? It follows from theorem 1 that says angle at center is twice the angle at circumference. Now, let's do a construction here. We can join A to O. I believe I'm not too fast. Okay. And join B also to O. And we have this angle at the center. Okay. If I have this angle as angle at the center, let me just write 2x at the center. You know this angle at the center, right? And we said, so in one state that angle at the center is twice Thank you. The angle at center is twice the angle at what? Circumference. So if this is 2x, let's pick this one here. This one will now be angle at circumference, which is x. Okay, this angle is also angle at where? Circumference to this one, to this angle at center. So if this is 2x, this is also x. If this is 2x, this is also x at the circumference. Can you see now? If this is 2x at the center, this is also x at the circumference. You can now see that this is x, this is x, this is x, this is x. All are equal. Okay? So it doesn't matter. Look at it. If I draw this one now, and I have this angle here, this is center. I have this. Okay, I have maybe a chord actually, and this chord subtends this angle is center, and I have another angle here from this same chord. Let's call this chord AB now. You know, this is at the center now, and this segment is a major segment. We now want to form another angle by this chord in this segment, and this angle here, let's say it's formed on this part like this. Okay. This angle form here, you know, is something like this. Is angle at the circumference. It's not necessarily it should be up. That's why understanding of each of these theorem is very, very important. Some people think once you see it like this, only when you have it at the center and you have this angle at the center, it's now formed. It must be like this. Up. No. This same angle here is similar to this one, just that this one is, you know, straight up, while this one is bent. They are all, the point here is that this angle and this angle, they're in the same segment on the circumference. That's all. So once it is on the circumference, it's corresponding to this angle at center. So if this is 2x, this should be x. Angle at center is twice the angle at circumference. So let's understand that particular theorem. If you are just joining us, you are in the right channel for mathematics. So do well to subscribe and also share this video and give it a thumbs up. Thank you. So we continue from here in our next class to look at some other theorem. Okay, we appreciate you for connecting, for joining, and for staying tuned. So do well to stay tuned and see you next class. Bye for now.